Okay, for Introduction to Statistical Learning, we are in Chapter 2, Question 2, Question 2A to 2C. We are given three different scenarios here, and we are asked a few things. So first we're asked to determine whether each problem seems to lend itself to either classification or regression, whether or not we are interested in inference or prediction, and then to finally provide the n, the number of data points, as well as p, the number of parameters or predictors that we're using, according to the question. Okay, so first one. Well, actually, let me just say a little bit about classification and regression and inference and prediction. So generally, classification methods are generally used for prediction case, right? We want to know whether the stock market is going to go up or down, into the class up or class down. We are classifying images in something like a neural network, and we want to know if we're looking at a cat or not a cat, or whatever the case is. Okay. One of the features then of these classification methods is that they tend to be a little bit like a black box. That's a little bit of an unfair analogy, but normally we put data in on variables that we understand, right? So in the first question here, we have data on profit, number of employees, industry of the CEO, etc. And so these are data that we can make sense of. We know what it is to have $500,000 in profit. We can make sense of that. And we know what it is to have 13 employees, etc. But many of these classification methods, these get combined in ways that are not intuitive for us to understand. Okay, and so they abstract that data and then use that abstracted data to make predictions that can be fairly accurate. Okay. Conversely, regression methods. So here's an example of a regression down here. Regression methods tend to retain data in the original form, right? So the things that go in are things like profit, employees, industry, okay? And those things, their importance is given by trying to estimate something like a coefficient in front of it in linear regression, for example, right? So the alpha says how important profit is in predicting salary, okay? And so regression tends to lend itself better for inference than do classification methods. But we can also use regression methods to predict salary, right? So here we're saying that salary is just a function of our inputs, of our explanatory variables. So we can also use regression for prediction. The last thing I want to say is that even though I've kind of presented it there as though these are hard and fast rules for regression and classification, there are some gray areas. So for example, there is a type of regression that we get into later called logistic regression that uses regression, but the outcome is to classify the outcome, right? So we might classify salary here as high or low, or above $500,000 and below $500,000 salary, or something like that. And the explanatory variables go in just like this, and at the end we can say, okay, well, the company's profit is alpha important for whether or not a CEO's salary is above or below some threshold. So these are general guidelines, but there is some crossover and some gray area in terms of regression, classification, inference, prediction, etc. Okay, so the first example is we collect data on 500 firms and record the profit, number of employees, and the industry of the CEO, the industry and the CEO salary. We are interested in understanding which features affect CEO salary. Okay, so first, we are interested in the features that affect CEO salary. So we are trying to make inference about these different factors affecting CEO salary. So we are interested in inference, and and we will probably use something like regression, because regression is typically better for inference. Okay. We also want to know the number of samples. Okay, so it's we have 500 firms. 500 firms. Okay. And I don't like how that rendered. Sorry, let me pause this for a second. Okay, so back. Our N is 500 firms, and our P, the number of parameters or predictor variables that we're using, okay, is 3. Profit, number of employees in industry. Okay, so again, if it's regression, a regression may look something like this, where we have each of the explanatory variables, and their importance will be estimated with the Greek letters here, alpha, beta, gamma. Okay, but we could also just plug, once we know or we estimate alpha, beta, gamma, we could just plug values in for profit, employees, and industry to then predict salary. So, okay. The next one. We are considering launching a new product and wish to know whether it will be a success or failure. We collect data on 20 similar products that were previously launched. For each product, we have recorded whether it was a success or failure, the price charged for the product, the marketing budget, competition price, and 10 other variables. Okay, so we're down here. This is a classification problem. We are trying to classify products as success or failure. Okay? And the reason it's important is because we want to predict the outcome of our product. Okay, so that's the first part of the answer. So our N is 20 similar products that were previously launched, and then our number of predictor variables is 13. We have price, marketing budget, competition price, as well as 10 other variables. Okay, so again, we'd use a classification method here. And so this might be something like a neural network or something like that. But again, we also might use a method such as logistic regression, which is a regression, and we can use it for inference, but it will also classify data as success or failure in this case. Okay? And finally, we are trying to predict the percent change in the US dollar to euro exchange rate in relation to weekly changes for other markets around the world, for stock markets of other countries around the world. Our data is the weekly data from 2012, and again, what we are using to predict is the change in the U.S. market, the change in the British market, and the change in the German market. Okay. So this is probably a regression problem. And now, we might also use a classification method here. Again, the boundaries kind of break down, but I can imagine using something like, actually, no, I can't. So why isn't this a classification problem? The reason this isn't a classification problem is because we're not trying to predict whether the rate goes up or down. What we are trying to pin down the actual number that it will land on, okay? And so we are not classifying here. We are trying to find an exact prediction. So we are going to use regression, but we're not using regression for inference as we did in example 2a. We just want to predict the outcome here. So again, something like a regression may look something like this. Okay, I won't go through that here. What is our N, our data? Well, it's the 52 weeks of 2012 from the different markets. Okay. And then the P, number of parameters we're trying to estimate, or the predictor variables, is the change in the US market, the British market, and the German markets. Okay, that's all. Thanks.